Liam here. On the 11th of August 2026, someone pushed the first commit to a new repo, remove AI watermarks from text and files with nothing but Python and the standard library. 49 commits later, 4 days later, it was tagged v040. We are going to read it. 4 days, no dependencies. That is the thesis. Gillemmeyer / watermarks remover. Agent skill plus stdlib Python scripts to strip multi-vendor AI provenance marks from text and files. The first thing you notice, no claim about beating any specific detector. The scope line is surgical, marks from text and files, not from the model, not from the human, the artifact. 3 layers, layer A, invisible Unicode, 0-width characters, soft hyphens, unusual whitespace that survives copy-paste and breaks diffs. Layer B, statistical rewrite, changes the token probability fingerprint without altering meaning. Layer C, C2PA metadata, exif XMP, the provenance chains embedded in image and document containers. 3 different forensic surfaces, 3 different scrub depths. The numbers before we open a single file: 4, 370 lines of scripts across 16 Python files, 1, 858 lines of tests, 512 lines of docs. 49 commits, 2 Docker files, 4 days, 7 tags from v0, 0, 1 to v0, 4, 0. The author iterated through 4 release cycles in the same window. What are the files? The structure is sharp, container meta. Pi at 855 is the heaviest, that is the exif XMP and C2PA strip, image meta. Pi at 668 is second, text Unicode. Pi at 449 rewrite text. Pi at 436 common. Pi at 428, a cluster of 5 scripts carrying most of the weight, then the CLI leaves below 150. The bar chart in LOC order, container meta. Pi at 855 is not over-engineered. It handles ZIP containers, PDF, PNG chunks, JPEG APP segments, and C2PA jump boxes. That is 5 format families in one file, image meta. Pi at 668 handles the same formats at the pixel layer. The scripts are sized to their problem surface. Text Unicode, Pi and rewrite text. Pi are the text path, Unicode code point removal and the statistical rewrite. 449 and 436 lines, common. Pi at 428 is the smallest of the 5 heaviest scripts and the most imported. That asymmetry is the signal, common. Pi is small because it has to be. 13 scripts depend on it. Test-to-script ratio 1, 858 lines of tests against 4, 370 lines of scripts. That is 0, 43. A token test suite sits between 0, 05 and 0, 10. This is not coverage theater. Every major path has tests, and the head commit added 253 lines of them for a single guard function. How do the scripts connect? The import graph is a clean 3-tier fan. CLI leaves at the top, clean text, inspect text, clean file, inspect file, thin entry points, some under 100 lines. Format engines in the middle, text Unicode and image meta handle the format-specific work. Common, Pi at the bottom, everything routes through it. No cross-tier dependencies, no cycles. Imported by common 13 scripts, text Unicode 6, image meta 6, container meta 3, audit lib 2, inspect file 1. This is a fan, not a mesh. The most imported module is not the largest, it is the shared contract. Common, Pi is small because it has to be. 13 things pull on it. Nothing crosses tiers. A CLI leaf does not reach image meta without going through common. You can swap a format engine, replace text Unicode, and every caller picks up the change for free. The architecture is separable. The tiers are not just a naming convention, they are an enforced dependency rule. Inspect and clean are paired at every layer. Inspect text and clean text both use text Unicode. Inspect image and clean image both use image meta. Inspect file and clean file use all 3 format engines. Inspection is not a stepping stone to cleaning, they are separate entry points against the same engine. You can run the entire stack read-only. Audit Dire and Audit Website have no clean counterpart. When was it built? The commit histogram: 11 commits on August 11, 20 on August 12, 17 on August 13 including the v040 tag, 1 more on August 14 after the tag, and that is head. The entire project history is 4 days. The bars sum to 49, equal to the commit count from Git rev list. No gaps, no frozen years, no long tail. The cumulative curve: 0 before August 11, 11 commits by end of day 1, 31 by end of day 2, 48 by end of day 3, 49 then the tag. The slope does not decay, day 2 has the peak. The project was not built gradually, it was front-loaded and released. The first 11 commits land on 11 August 2026, the day Anthropic announced global text watermarking. Standing start to v040 with CI 1, 858 lines of tests and 2 Docker files in 4 days. The date coincidence is verifiable from Git log. We are stating it as a coincidence, not a claim about the author's motive. What is not a coincidence? The scope of what shipped in 4 days. A test suite at 0:43 ratio. A CI pipeline. 2 Docker files isolating the optional layers. A 3-tier architecture with no cycles. That architecture does not happen by accident at this pace. The scope document. The file we want to read is not a strip implementation. It is ethics. MD, the scope document the agent loads before doing anything. 32 lines, shorter than any of the strip implementations. Read it. A removal tool that ships a document telling you removal proves nothing is making the same argument this channel has been making all week from the other direction. The detector's silence is not evidence of absence, and neither is the remover's success. Lines 5 to 10, appropriate privacy, strip provenance from your own files before sharing. Engineering hygiene, invisible Unicode breaks diffs, search, paste. Research, understand how text and C2PA marks work across vendors. Cleaning your own drafts where policy allows. Lines 12 to 16, not appropriate, academic fraud or misrepresenting AI assistants where disclosure is required. Circumventing lawful transparency or platform disclosure rules. Claiming clean content is human written for compliance theater. 3 explicit prohibitions, each naming the failure mode. Line 18, verbatim, a removed mark does not mean the content was never AI assisted. Use this toolkit honestly. That line ships with the tool. It is not a disclaimer buried in a license, it is the scope document the agent loads. Lines 22 to 26, honesty in reports, always separate, verifiable removals, what you can count, Unicode removed, metadata actions taken. Best effort statistical rewrite, no gold undetection claim. Out-of-scope channels, audio, video watermarks, secret key detectors, training backdoors. The tool reports what it can verify and names what it cannot. Line 28, do not imply that a successful C2PA/metadata strip means no AI provenance left. Soft-bound and synth ID class media signals can survive. The tool tells you it is not the last word. That is a design decision, not a legal hedge. The binary guard. The head commit inspect text. Pi picks up a new argument, force text. The read text input call gets allow binary equals args, force text, behind that common, looks binary sniffs magic numbers plus a control byte ratio, and guard binary refuses with a message before touching the file. 8 files changed, 482 insertions, 16 deletions. The pre-guard behavior in clean text. Pi, you point it at a docx, it decodes compressed bytes as text, calls that findings, then writes the mangled decode back. The output still passes zip file. Is zip file, the end of central directory record survives, but reading a member raises. The tool reported removed equals 1 and silently corrupted the file. The head commit adds 253 lines of tests for this one change. They cover magic number detection, heuristic detection, the force text override, refusal without writing or backing up, and that clean file. Pi still routes a docx to the container path, 253 lines to gate test 1 guard. What does it need? The dependency audit. Every import across all 16 scripts is standard library. Argparse, collections, data classes, gzip, eo, json, os, pathlib, re, struct, subprocess, sys, temp file typing, Unicode data, erlib, xml. A tree, element tree, zip file, zlib, plus the repo's own modules, nothing else in the core. No model, no GPU, no third-party package in the core. The Unicode strip is re in Unicode data. The metadata strip is struct, gzip, and format-specific byte manipulation. The statistical rewrite is SciPy and Torch, but those are optional, isolated behind a separate requirements file and a Docker file. The core installs with 0 packages. Requirements dev txt pytest equals 9, 1, 1 and pipaudit equals 2, 10, 1. Both are test tooling. Pipaudit is the supply chain auditor. The project audits its own supply chain. The production install has no requirements file because it has no requirements. Layer B and control region are optional because they add weight the core does not need. Control region is external pixel removal, different attack surface, different runtime, different trust model. The Docker files isolate them. The project is explicit about what the core does and what it does not. Sources: Gillum Emire / watermarks remover, clone 2026-08-14. Head commit 256D90D. All data computed by git log, wcl, git grep, git show, repo verify. MD has the commands and their outputs. Ethics. MD quoted verbatim at 5 byte exact ranges. Every import across all 16 scripts is standard library. The only pinned dependencies are pytest and pipaudit. The marks a major lab shipped worldwide come off with re and Unicode data. Your turn, clone the repo, run audit dir. Pi on a directory of your own text files, documents you wrote, drafts that may have AI in them, anything. Read what comes back, then read ethics. MD again because the tool has already told you a report is not evidence. The detector's silence is not evidence of absence. The remover's success is not either. What you do with that is the question.